Right, here's a graph of a function y equals to f of x. And it's probably very crazy piecewise function. So I refuse to write down the formula for it. But there are a few things I can ask. I can ask everything that we learned before exam 1. So for example, what's the limit of x going to 2 of f of x? And then b, what's the value of 2? And c, I can ask, is fx differentiable at x equal to 2? Why or why not? And then D, find all values, x values, where f of x is not continuous. And E, you can ask, find all x values where fx is not differentiable. Let's try to think about these questions. First, A and B are just a review from exam 1 part. What's the limit of the function as x goes to 2? 1. So if you invoke Jim again to go to location 2, as he's getting closer and closer to that location 2, he reports back that his altitude is getting closer and closer to 1. Whereas, what's the actual value of the function at 2? 3. Now the question is f of x differentiable at x equal to 2? It's not. The answer is no. Can you explain why? Because it's not continuous. That's the easiest way to say it. Okay. So simply no, because it's not continuous. So that's perfectly fine answer for this. If you want to go further, however, you can kind of really argue with the definition. F prime of 2 is limit h going to 0 of f of x, f of 2 plus h minus f of 2 over h. But since limit of h going to 0 of f of 2 plus h is what? We got it here, right? It's 1. And f of 2 is 3. And you can just write some more, and 1 minus 3 is negative 2. So top is negative 2, whereas the bottom is 0, negative 2 over 0 type. Does the limit exist? No, it cannot exist. Okay, so that will be a more longer argument. You're free to write such a thing. I'll be impressed. But this is fine, perfectly fine. Okay. All right, find all x values where fx is not continuous. Okay, can you identify points where the function is not continuous? Being continuous just means it's unbroken, right? So you just have to identify points where the graph is broken. Where's that? This is, for this is -1 and 2. Those are the places where the graph is broken, right? Now, what about this next question? Find all x values where the function is not differentiable. Okay, any non-continuous points, any points of discontinuity will be not differentiable, right? But in addition to this, it is possible for a function to be continuous and non-differentiable. What is that point? 3. Because you have a sharp turn. Right? The slope on the left side of that point and the right side of that point is different. Therefore, it's not differential.